All right, guys, here we go. Let's read the objectives together. It's 1, 2, 3. I can solve and graph compound one variable inequality. So yes, we've been looking at one variable inequality. So for your title, for your notes, write compound one variable inequality. And compound, I'm going to explain what they are. And this is where we start putting all the pieces together. You're going to see how it's a little challenging, but you'll see how everything comes together like pretty neat. Okay? So we know what one variable inequalities are. We're still on the same concept. Okay? Gave you guys definition, example, non-examples. We know our steps. If you notice on the top left, I included the steps: simplify, isolate, plot, and check. Have we been using those? Yes. Yes. Now check this out. From this point forward, I need you guys to pay full attention. Pens down, pencils down, focus. So what are compound inequalities? I'm going to explain them as easy and as simple as I can. I just need you guys to focus. Here we go. You're just paying attention. You're not writing anything. Here we go. We know how to solve the following inequality. And once again, you're not writing anything down. And we have -5 is less than x plus 1. We know how to solve these simple inequalities by leaving the x by itself, which the inverse of adding 1 is subtracting 1 to each side. So therefore, this is 0, and we're left with -6 is less than x. Are we there so far? So to graph this, I get my graph going. I got 0, -6 over here, and this one does not include the 6, right? So it's an open circle, so there it is. To graph this, it says -6 is less than x. So what number can I substitute in the x to make this true, where -6 is less than that number? 23 or anything to the right. Are we there so far? So we know these simple ones. Let me go to the next one. If I gave you this one, to solve this, I subtract 1 from each side. Those ones cancel. We're left with x is less than 1. To graph that, here it is. I get my 0. 1 is right there. Does it include the 1? No, it's an open circle. And I read it. X is less than 1, so everything to the left. So far, so good. Yeah. Okay? So now, compound inequalities. Compound means combine. Compound means combine. Now check this out. What I need you to look at is that, notice this first inequality, you're just paying attention. This one has x plus 1. However, this one also has x plus 1. Do you guys notice that? Well, look what I'm going to do. I'm going to combine these two. Pay attention. I'm going to bring this down. Bring this one down. This right here, I join both inequalities together, and that is what we call a compound inequality. Okay? So, with that said, on the left-hand side of your notes, left-hand side, I want you to write compound equal combine. Compound equal combine. And in blue, I'm going to write with blue the definition for compound inequality. A compound inequality is two inequalities combined into one. Compound inequality is two inequalities combined into one. Does that make sense? Yeah, the way I showed it, right? We have two different inequalities. We combine them into one, and it becomes a what? A compound inequality. Are we there? Okay, so Any questions what a compound inequality is? Okay, for those of us that missed it, here it goes again. I gave you one inequality, I gave you the other inequality. Identify that this is the same as this. A compound inequality is by combining both of them to make one inequality, which is this one. And things to notice that this one now has two different inequality symbols. Does everybody notice that? Yes. Okay, so with that said, right there where you have example 1, copy this please. You don't have to copy the text, just copy the inequality, the compound inequality. -5 less than x plus 1 less than 2. Okay, and let's solve this together. Now, if I was, check this out guys, if I was to cover this part, and I asked you to solve this, what would be our first step? Subtract 1. But if I move this over and I cover this side, cover this side, once again, what would be our first step? Subtract 1. Therefore, in order to solve that compound inequality, I need to subtract, I'm going to do that with red, subtract 1 from here, well, with blue. Subtract 1 from there, subtract 1 from here, and subtract 1 from there. So these cancel. We're left with -6 less than x less than 1. Copy that, please. Okay, let's continue. So we already solved it. Let's graph this. So underneath, and throw that away. Underneath that, let's graph this. Zero, 1, -6. Okay, with red, I'm going to graph the first part with red. So I'm going to underline this first part of my compound inequality, and I'm going to graph that part. So check this out. -6 is less than x. So is -6 included? No, it's an open circle, right? Just to mark our spot. So let's read it. -6 is less than x. What number can I substitute for x that would make that true, that -6 is less than that? Anything to the right, including 23, right? Everything to the right, right? Okay. Now that I graphed my first solution set, now I'm going to do the second part. I'm going to graph this in green, the second part. And it says, x is less than 1. Do we include 1? No, it's also an open circle because it doesn't have the equal sign, right? Let's read it. X is less than 1. What numbers are less than 1? Anything to the left. So we shade that way. Okay? So I'm going to highlight, if you want to do it with your pencil, but I'm going to highlight so you can see the two regions that intersect. Does everybody see the two colors intersecting? Yes. Here, I'm going to highlight it so you can see it. There it is. That's the solution set for this compound inequality. Now, check this out. When we have two regions that intersect with a compound inequality, this is what we call an and compound inequality. Right, this word right above that, where the regions intersect, I want you to write the word and I'll explain why. So let's see. Let's go through our steps. Did we simplify? Yes. Did we isolate? Yes. Did we plot? Yes. So now we need to check. So let's write check. I'm going to rewrite this. -5 less than, open parentheses, plus 1 less than 2. All right. Now check this out. What we're saying is that this intersecting region is my solution set. So I just need to check a number from in there. What number would we use? What would be the easiest number? 0. So I'm going to substitute 0 in here. 0. There it is. So let's see. What is 0 plus 1? 1. And I bring everything else down. Negative 5, less than 1, less than 2. So now, let me check it. From left to right, I'm going to read it and see if it's true. Is negative 5 less than 1? Is 1 less than 2? Yes. So therefore, we highlighted the correct solution set. Everybody with me? So now, we have our check, we have simplify, isolate, plot, and check. However, what was the last piece that I'm asking you guys to write? The notation set. So here we go. Let's write it. Notation set says, the set of all real numbers x, there it is, such that, what is my inequality that I graph? Negative 6 less than x less than 1. That's my notation form of my solution set. Now, what does that mean in words? Here it goes. Check this out. In words, I'm going to read this graph in words. All these numbers in here, all these numbers including decimals, negative 5.9999, 1 point, no, not 1 point, it's 0.75, 0.79999. All those numbers in here are all real numbers. Is that correct? So this could be read, all real numbers x. Let's see, what are all these numbers compared to negative 6? All these numbers. Greater. So therefore, all real numbers x greater than negative 6, comma, not but. If it's included, what was the word that we used? And, double underline that, less than 1. That's what it means in words. Once again, let's see. This is our solution set, and it says all real numbers x, okay, so far so good, greater than negative 6. Yes, all these are greater than negative 6. And less than 1. Is that correct? Yes. So let's see all our pieces. Simplify, isolate, plot, check, and our notation set and our words for the notation set. All right, so far so good. Let's copy this next example, please, and let's do it together. Here it goes. Example 2, copy that. 8 less than 3x minus 1 less than or equal to 11. Once again, 8 less than 3x minus 1 less than or equal to 11. Okay, let's do this one together. Let's see. To solve this inequality, if I was to cover this side up, let's say, if I was to cover this side, what do I need to do in there in order to start solving that inequality? Add 1. How about if I cover this side? Add 1. So therefore, we need to add 1 to everything. So add 1 here, add 1 here, and add 1 here. These cancel. We're left with 9 less than 3x less than or equal to 12. Turn to your neighbor, let them know what's the next step from there. What's the next step? We still have the x that has a number next to it. If it's multiplying, the inverse is to divide by 3. Divide by 3, divide by 3, everything. This becomes 3 less than, 3 divided by 3 is 1 times x, that's x, less than or equal to 4. So let's see, simplify, isolate. Let's plot our solution. Plot. Here we go. We got 0. 3 is about right here. Space it out for the 4. 4. So like that we can have enough space so that we can see the region. All right, I'm going to graph my first part of the inequality in red. I'm going to underline the first part in red. And it says 3 is less than x. Does it include 3? No, it's an open circle because it doesn't have an equal sign. So it says 3 is less than x. What number can I substitute in here that would make that true, that 3 will be less? 4, anything to the right. That way. Draw an arrow at the end just to indicate that. I'm going to graph the second part in green, the second part of my compound. Let's see. X is less than or equal to 4. Does it include 4? Yes, because it has an equal. So this one we actually plot our point right there because it does include 4. And it says X is less than 4. What numbers are less than 4? Everything to the left with an arrow at the end. There it is. Do you see the intersecting regions right here? Yes, so this is our solution set. And what are we going to write right above it? And. So whenever we have regions intersecting, it's an and compound. So simplify, isolate, plot, check. Check is our last step. I'm going to rewrite this. 8 is less than 3, open parentheses, minus 1, less than or equal to 11. Now check this out. Out of this intersecting region, which number would you use in order to check it? Could we use 4? Yes, because notice that we actually plotted a point. This is a solid point. Let me show you again. So we are able to use 4. How about, could we use 3.5? 3.1, 3.0009, 3.56. How about 3? No, because this one is an open circle and it's not including 3. So I'm going to test 4. I'm going to substitute that in here. What is 3 times 4? 12. I bring down the -1, the inequality symbols, the 8, and the 11. Let's continue simplifying. What is 12 minus 1? 11. I bring everything else down again. 8, the inequality symbols, and the other 11. Let's read it from left to right and see if we are correct with the way we have our graph done. 8 is less than 11. Is 11 less than or equal to 11? Yes. So therefore, yes, that is correct. Our notation set. Here we go. The set of all real numbers x, there it is, such that, okay, what comes after? 3 less than x less than or equal to 4. Okay? And where did we get that? We got it from here, from the inequality that we used to graph our solution set. Let's write it in words. This means, and I'm going to use, everybody look up, I'm going to use a graph to write my words. All real numbers x, let's see, all these are x. What does that compare to 3? Greater than 3, and I double underline that to remember, and all these are x compared to 4, what are they? Less than or equal to, because did we include 4? Yes, equal to 4. And we're done. Okay, so I'm going to give you this next one. Copy it and do it by yourself so you can get some practice. Here we go. Copy this next one. -9, this is example 3. -9 less than x minus 10 less than -5. Do that one by yourself. Go step by step. Simplify, isolate, plot, check. Write your notation set and write it in words what it means. Go. Okay, so our first step. In order to solve for x here, we need to get rid of this minus 10. So the inverse is to add 10 to each side. Add 10, add 10. This cancels. We're left with 1 is less than x is less than 5. Hands if you got that. Okay, let's graph this. Now, this next step is where some of us start messing up in regards to our answers. We need to make sure we do it step by step. Here's 0. I got 1 here. I got 5 over here. And I'm going to graph the first part in green. Does it include the 1? No, it's open circle because we don't include that point. It doesn't have the equal sign. Let's see. 1 is less than x. What numbers can I substitute in here to make that true, that 1 is less than that number? Anything to the right, including 23. That is correct. That way. I'm going to graph the second part in blue. X is less than 5. Does it include 5? No, it's an open circle. What numbers are less than 5? Everything to the left with an arrow. Now, who sees the intersecting regions here? That is our solution set. To check, you write your inequality, -9 less than, open parentheses, -10 less than -5. You choose any number that's in your solution set. I'm going to choose number 2. 2. Is 2 part of the solution set? Yes. Let's see. What is 2 minus 10? That's -8. I bring everything else down. The -9 less than -5. And I'm going to read it from left to right. Is -9 less than -8? Yes. Is -8 less than -5? Yes. So therefore, my solution set is correct. Now I'm going to write up here and. So I know that they intersected and it's an and compound inequality. From there, our set notation is the set of all x's, or real numbers x, such that, what is my inequality? 1 is less than x, which is less than 5. And what does that mean? It means all real numbers x greater than 1 and less than 5. Hands if you got that by yourself. Okay? All right? All right. Copy this next one down. Example 4. Example 4. 8 plus t greater than or equal to 7, or 8 plus t less than 2. Okay, pens down, please. Now, who noticed that this is not exactly the same as what we just did? It's not exactly the same because these are known as or compound inequalities. Let me show you how to solve these. Check this out. I'm going to solve the first part of the compound. To solve this, I need to leave t by itself, so I do what? Subtract 8 from each side. I'm left with t is greater than or equal to -1. So simplify, isolate, plot. I'm going to plot this. You're just paying attention. 0, -1 is right here. And I'm going to graph that in red. Does it include the -1? Yes, so I plot my point. T is greater than that. All the numbers to the right. There it is. Now I'm going to solve my second one. I'm going to do that in green. Same thing. To solve for t, I subtract 8, I have t less than -6. So negative, is that -6? Yeah. -6 is right here. Does it include the -6? No. Open. Let's see. T is less than -6. What numbers are less than -6? Everything to the left. Now, on this one, what do you guys notice? That they do not intersect. These are known as or. However, did we graph them both on the same graph? That's why they're known as compounds, because we compounded both graphs. Are we there? And the rest is the same. You do the check, and you do the notation the same. Okay? So with that said, homework is found on pages 174 to 175, numbers 2 to 40 even. Turn in your homework on your way out. Have a good one, guys. Enjoy your homework. See you guys tomorrow. Read into a little bit on the or in case you didn't get this last part. So like that, you can go ahead and finish the second portion of the homework. Okay.